Okay, guys. All right, now we are going to study this unit. We are going to study chiller unit. This is a chiller unit. What is the difference between this chiller unit and this self-contained unit?
The condenser and the evaporator are separate, and that one is together.
No, look at this. This is the condenser, and this is the evaporator. This is the condenser, and this is the evaporator.
It doesn't use Freon.
Excuse me?
It doesn't use Freon.
No, I have Freon here. I have Freon here.
It's still inside the pipe.
Excuse me? Excuse me?
That one is moved by water.
No, this is raw water, and the raw water here enters here and goes out here. I have raw water. Follow me.
This one uses a freshwater system to cool.
Excuse me?
This is
One's separate and one's
a
together.
unit.
No, my friend.
This is split. This is
No.
That's a chiller system.
Pay attention.
Those pipes are
This
white and
this element looks like a split unit with the condenser over there and the evaporator here, like that, like this one, a split unit.
okay.
Look.
But it
This is the split unit.
okay.
Condenser in the engine room and evaporator in the cabin. This is a self-contained unit with the condenser here and the evaporator here together. Yes or not?
Yes.
Pay attention. This is a self-contained unit. You have the condenser here, compressor and coil, and you have the evaporator here.
So it's the same.
So you can have multiple. What is that called? In many cabins. In
Look
many
at this.
cabins.
It's pretty close. The difference is this. The coil of the evaporator. Look at the coil of the evaporator in this.
Oh, it's internal.
The coil of the evaporator is cooled. In this case, the coil of the evaporator is cooled by
Refrigerant.
the coil of the evaporator with the refrigerant internally is cooled by air. The air, the motor, suction the air, and you have in the evaporator. Okay, pay attention. The coil of the evaporator here, is cooled by,
The water.
in this rectangle, in this box, you have fresh water or coolant, engine coolant, with glycol and water. 1 second. Because this is a little difficult to understand. We are going to refresh the split unit. The cycle starts in the compressor. The compressor receives the signal from the thermostat, and the compressor starts to compress the refrigerant. In the output, in the discharge of the compressor, you have refrigerant at high pressure, high temperature. Yes or not?
Yes.
The refrigerant passes for the dryer filter, and after that for, what is this?
The capillary pipe.
The capillary pipe. What happened here with the refrigerant after the capillary pipe
Reduces temperature, reduces
is
pressure.
low pressure and low temperature and enter in the bottom of the evaporator and start the process of evaporation of the refrigerant. And the refrigerant goes out here fully evaporated and return in the discharge port of the compressor, and the cycle continues. This is the refrigeration cycle. Yes or no?
Yeah.
Yes.
Pay attention. When the refrigerant enters in the bottom here, how is the pipes?
Cold.
Is frozen. And the pipes here are practically frozen. When this blower, when this motor starts, suction the ambient air, and I receive here
Cold air.
cold air because the pipes are frozen. What happens if I pass around those frozen pipes? No air. I surrounded those frozen pipes, not with air, like this. What happens if I surrounded those frozen pipes with fresh water? or coolant.
So it's what?
That water become
Freezing.
chill water.
Cold water.
No? And that chilled water, I move the chilled water with this fresh water pump, electrical pump, into that coil. In that coil, internally in the pipes, is circulating coolant, fresh water, or refrigerant. Fresh water or
Fresh
coolant.
water. Cold water.
Cold water, chilled water. And the chilled water return here, enter again in the box, and the frozen pipes chill the water again, and the water goes over there. And this blower start suction the ambient air pass around the chilled pipes, and I receive here what? Cold air. What is the name of that unit?
Air handle.
Air handle. And what is the name of this complete unit?
Chiller.
Chiller unit.
The chiller system.
Everybody follow me?
Yes.
Okay.
Why
Pe-
would you use a chiller unit other than
Yeah, let me explain that. Some people say in a chiller unit, pay attention, in a chiller unit is wonderful because I only use water, fresh water. I don't use refrigerant. That's true?
No.
You use refrigerant?
Yes.
Yes. you-
Where?
In the
In
compressor.
the compressor.
Here, in between both of them. This is the compressor, compress, pass for the coil, and return. Yes or not?
Yes.
Yes.
Ah, no, I have a self-contained unit. The only difference is in the evaporator is surrounded not for air, it's surrounded for fresh water. And that fresh water becomes chill. And I circulate that chilled water over there and return here. You like it?
Yes.
Ah, excuse me. Yes, I have refrigerant in the central chilled unit located in this building. In the other offices, I have air handles. The communication between this central unit and the air handles is with pipes and fresh water. I don't have refrigerant traveling longer distance. I have fresh water traveling long distance. Everybody follow me?
Yes.
Pay attention. I have the central chiller unit here in this building. And the lady of this building, the lady of the accounting department is complaining about a leak of some liquid. The color is green. She thinks that is refrigerant in the office. And she said that the air is warm. The technician of the facilities of the university goes over there and calls to the manager and say, yes, in the office of Mrs. Adriana, there are a lot of refrigerant on the ground.
It's coolant.
This is refrigerant?
No.
No, it's not refrigerant. It's coolant. Because the people, instead of use fresh water, the people prefer coolant. Engine coolant, motor coolant. Why coolant instead of fresh water?
So it doesn't freeze.
The freezing point is lower, and additionally, the additives in the coolant avoid corrosion in the pipes of the evaporator. For that reason, it's better the coolant. The coolant is green color, similar to the color of the refrigerant, but this is coolant. It's not refrigerant. It's not freon. That's clear? All right?
So
Okay.
it's safe to say most people that have chiller units, they go for having a coolant instead of fresh water?
Pay attention. You have only refrigerant here in this unit.
Right.
In between this unit and each air handle in each office, you have fresh water or coolant.
Right. But I'm saying the people that own chiller both for chiller units, they usually prefer to use coolant.
Of course. No, the
But
owner is the technician.
Oh,
You
the technician.
install that one and you recommend coolant.
Okay.
Because with fresh water,
It corrodes after
it
a while.
corrodes everything. Fresh water is good. If in some cases you don't have a coolant, you use fresh water, but the
Well-
recommendation is coolant.
You wouldn't even see the refrigerant, wouldn't you? Unless you use a dye. Because in ambient temperature it's vapor, so they wouldn't even be able to see.
For what?
Because you're saying that she saw the leak and she said it's refrigerant. But you wouldn't even see it.
No, pay
because
attention. In that particular situation, what was the problem? The technician found a lot of coolant on the ground.
It's coolant.
Okay, it's because one of the pipes, or this pipe, or this pipe is leaking.
No, I get that, but I mean, it wouldn't even be refrigerant because she wouldn't be able to see it. So that wouldn't even be.
She's saying the Freon would evaporate.
Yeah.
So that's how you know it's not Freon. Because the boiling point of Freon is negative 22.
Not Freon, refrigerant.
No, pay attention. You are confused.
Because this part is going to be separate from.
This part
I
is completely separate.
I understand that part.
Look, the refrigerant is Freon. Refrigerant is Freon. Is here. The other one is coolant. Is water and glycol.
I understand that, but she's saying that it was refrigerant. But now you wouldn't even see the refrigerant, even if it was that, because
No, you need to explain to him. Hey, my friend, this is not refrigerant. This is coolant. That water that you found on the ground is coolant.
Okay.
No, okay, but
She's confusing refrigerant.
I'm not.
She's
I'm
not-
not
the only
confused.
reason why
I'm
you're
saying that you wouldn't be able to see
She's
it.
not confusing. She's
The only
just-
reason why it will be they will think it's refrigerant is because of the color, because the refrigerant
But that's what I'm
doesn't
saying.
go
You wouldn't even be able to see
No.
the refrigerant because in ambient temperature it's vapors.
no,
Unless you use a dye.
No, mami, ven, déjame explain. Look at this. Normally, when you have a leak of refrigerant
It's gonna
in
be
this unit, for example, you have a leak here, you have a crack here, and the refrigerant is going out, immediately the refrigerant goes out to the environment, is evaporated.
That's what I'm saying. You wouldn't see
You
it.
don't have a pound of...
Okay,
no,
that's
nothing.
that
You
tells my
have a little green color here around the crack, indicating that in that point,
That it's
immediately goes
green.
out, is evaporated.
Okay.
That's not possible. Over there you have a pound of water, green water. This is not refrigerant because she is,
Right.
I agree with you, never is liquid at ambient temperature. It will be evaporated. That's number one. But too much technicians think that this is refrigerant. No, mijo. No, papa, this is coolant, engine coolant. Okay? And it's separated, like Felix said. In this element you have refrigerant. Over there you have coolant. Okay, turn off the cell phone, papi, please.
Chiquitos.
Mucho chiquito.
Mucho
I think that
chiquitos.
was actually Brooks.
Okay, pay attention. In a chiller system, you have two pumps.
Primary.
One pump for,
The raw water.
what is this?
Raw water.
Raw water.
Raw water. To cool
The condenser.
the condenser. And you have another water pump,
Fresh water pump. So
fresh water pump, to circulate,
The water.
It's a circulation pump.
circulating pump or fresh water pump or coolant pump, to circulate the fresh water or coolant. Ready? This pump is different than this.
In the video, you have a primary circulating pump and then a secondary. The secondary
Correct.
would be in the
some
return.
cases, that's great, thank you. In some cases, with one unit like this, how many air handles you have?
4,
6, 7, 10, 12. In that case, you need one pump to move in this direction, and other one to return. You have one here and other here, two circulating pumps. It's to improve the movement of the coolant.
And it would be the same size. The same size
Correct.
pump for each side.
The same pressure and the same flow. That's correct. The same pressure and the same
in
flow.
some systems, you don't have one on the return. You only have like 2 or 3 main ones on the
Yeah,
field, so we
you
can
can
just
install, instead of 2 here, you can install 2 in series here,
Okay, because if anything, it's still
and you
pushing
pump it
more.
faster.
you pump it fast.
Because you remember that the cycle is closed, and when you have a closed system, the pressure is constant. Great?
You use this system on boats as well?
Now pay attention. Now, every day is more popular in boats, in big boats, because you only have one unit, a small unit with refrigerant here, and the rest in between the master room and the central unit, in between the galley and the central unit, in between the flybridge and the central unit is
Separate, split unit.
no, it's not a split unit. It's pipes
Air
with the
handle.
coolant or fresh
you mean
water
this one, yes.
and air handles. You only have one air conditioned unit.
To go.
One
to
air
work
conditioned
on.
unit here in the center. What is the name of this box? This box,
Chiller?
chiller box,
No, chiller box. Yeah.
chiller box. What internally you have what?
Coils.
Fresh water or coolant?
In both you use fresh water or coolant?
Coolant,
Coolant.
coolant, always coolant.
How do you know how many handlers you can put on the
Okay,
system?
this is calculated.
Yeah.
This is calculated. I am going to explain at the end of the course to calculate that.
Okay.
But it's calculated according with the capacity of the
compressor.
the compressor. For example, you say, I am going to explain, the last class is that calculation. You say, I have a Hatteras 67 feet with one master room of 10 by 12, other two guest rooms 6 by 3, 6 by 3, the galley, tan. You added all of this and you calculate the capacity of the compressor and the capacity of each air handle and the grills. This is the last project,
But
project of this
you
class.
have to take in consideration
You need to take in consideration
the windows.
the windows, if it's sunny, if the material of everything. But this is the last project. It's a wonderful project. Okay. Pay attention. I have 3 air handles with this unit. The first air handle is the engineer office. The second handle, accounting. Number 3 is other department. In the second department, they complain about warm air. In the first air handle and the third one, it's good. The air is cold air. Only in the middle one, the air is warm.
I'm sorry, when you say air handles, it's like the air vents that are going.
No, the air handle is that unit.
Oh, that unit. Okay.
That unit. Pay attention that unit, Felix. This unit is like a remote evaporator.
Okay.
But it's not an evaporator because the evaporator is here, you see?
Okay.
Air handle, because look at this. The coil of this evaporator, the pipes, internally they have coolant.
Coolant, right? Yeah.
Coolant, chilled water. And this blower suction the ambient air here. Here is located the filter. The filter is here.
Right.
The air enters here and goes out cold air.
So with chiller systems, you will have one of these units per room?
Per office.
Per office?
Per office. One air handle per office, and
only
one
one of these. Okay.
and one
Well, depending
Thermostat per
depending on the capacity. Depending on the
yeah,
capacity.
and one per each office.
So the problem is
thermostat,
it's on thermostat.
In the accounting office, you have one thermostat.
Okay.
In the other office, other thermostat. In the accounting office, they want to turn off. This blower is off. The water continue because you have a T here, continue for the other office. This one is off. It's not used, but that one is used, and the other one is used.
Right.
That's correct?
Yes.
Okay, so your question is that
The
the
middle one
office
is warm, and the first one and the third one are
Are good.
okay.
Okay.
Probably this.
Yeah.
Probably the blower
Blower.
is not blowing enough. Probably this is clogged.
Oh, yeah.
That's the number one. This is clogged,
The most common.
the most common. And for that reason, the air is warm. But normally it's here or filter.
Okay.
Because if you had a leak, all the system would be bad.
Correct.
You're gonna see the lake because it has really good pressure in the system.
The lake.
Yeah.
But this
Not
is
the leak,
this
the
is
lake.
this
Yeah,
is
you're gonna see the
a
lake.
system that the people prefer every day, because you manipulate less refrigerant in between the central unit
You basically have
and
a
each air
refrigerant.
handle. You like it? What is the name of that unit?
Air handle.
Air handle. Air handle.
Handle, like a handle.
And internally in the air handle, you have, instead of refrigerant, you have coolant. You don't have refrigerant. Excuse me. Pay attention. Look, I have a T here, and I continue with other one here for other air handle, and other one more and more. I want to bypass this one because I need repair this one. But I need this and this and this, but I need bypass this one. Normally, you have valves here and valves here. You close the valves, you remove that unit, and
Everything keeps working.
and the other ones are working. To isolate the system. Universities, hospitals, they use chiller system. In this university, they have the central unit over there, and this room is one air handle. The other is other air handle, air handles. And we have in between this and this is fresh water, no refrigerant. That's good.
This unit doesn't have that T, so now would
No.
you cut and add that T, or would that be a unit specifically for?
Pay attention. Jasmine is asking about I want the heating mode in this building. How is the heating mode in this? I don't have white bulb over there. They have in between the blower, you remove the blower here, you have a resistor, a furnace. When you activate heating, the furnace is red. When the air pass here, pass through the red resistance, and the air over there is hot.
So cold
It's a
air
furnace.
mixes with the furnace.
It's a furnace located here in the middle.
Okay, but I got another question. When you're gonna add, let's say you have this unit and you're adding another unit, you said it has to have a T to bring the water.
Yeah.
Do you
And bypass here.
do you gotta cut that T out of there and put like an adapter, or?
Correct.
Dust that's
You install,
Yeah,
instead
it's
of that
all
T,
dust that's been-
you put a four ways. This, and this.
And how would you do that if you're not allowed to solder?
No, when you order the split unit, you order the split unit. When you order
Handle.
the handles, the
With
air
that in
handle,
mind, so I have to come with that already attached.
you say this one is. This is a great question. Sorry,
But
pay
it's not-
attention. Pay attention. This air handle is the last air handle in the system. Suppose that you have 5. This is the last one, because after this I don't have connection for other one.
Okay.
This is the last one.
So you have to order the other ones
The
with
other ones in the middle,
connectors.
they have instead of a T, you have a 4 ways to connect the other one and the other one. This is the last one of the series.
But it's not. I mean, on the boat that we were working, the one that I told you that we installed like 24 units. On that,
Hey, Papa, go ahead.
on that boat, we had to main feed all the lines. We had a 2-inch pipes, and then from every single one, we were just throwing the lines.
This
like,
is other
we
way.
were just getting the lines.
This is in
to each
parallel.
unit.
I love that one. Pay attention. They, from this point, they supply a discharge manifold, and from this one, other return manifold. And from
Okay,
the
so-
discharge manifold, you connect.
So they have each individual one, but it's like this closed off, but they have their own pipes going to each one.
Correct.
It's,
So
it,
that's
it looks
way
like
more
that.
pipes.
It's more
This is
efficient.
exactly. Those are the.
You
bulbs
remember,
that I'm
guys?
saying.
But you have a lot of
One
pipes.
second.
And you have a lot of pipes. Yeah. For
You
sure.
remember when I explained the central hydraulic unit in a boat? That I created positive,
Positive and negative
the
manifold?
negative? It's exactly the same. You can create from here one discharge manifold with 6 outputs, and other return manifold with 6 inputs. And from each of those input and output, you install one
Handle.
air handle connected to the return. This is in parallel. This is great because if this one is broken, I have the other ones working.
But now, if you do it in parallel, would you need more coolant?
No, it's the same. It's the same. More pressure, more flow. This is.
So you get more fun.
You need more flow when you connect in parallel.
Okay.
Correct. But you change the pump. When you design the system, you take a decision. It's only for 3 air handles. I'm going to connect in series. What is the disadvantage of the series connection?
The last one is going to be
The last
larger,
one will be affected.
And whenever
What is
you
the
have to
advantage?
change one.
Excuse me?
No, go ahead.
What is the advantage of the parallel connection?
They're all cold.
All of them receive the same pressure and the same temperature of chilled water, and they work equal. In series, the last one is affected.
Wait, so it's just like the electrical stuff?
Yeah,
It's exactly the same.
pretty much. Like the water, like the electrical,
Like the hydraulic,
Yeah.
it's exactly the same. Any other question in this?
Because you have-
I
you
love
have-
that system.
You have more resistance on the tube. So the last one,
Oh, when it's in series, yes.
like
Yes.
So,
No,
so I'm sorry. So you said that this is the type of system that's is being implemented now. Is getting more popular now but it's for bigger boats.
correct.
How come they won't use this type of system in smaller boats?
No, in this moment it's used in medium a small, medium boat, more than 40 feet, they use that one. Chiller system. No, Papa.
Yeah. And they have as well. I mean, on the older boats, you're seeing a lot of the split systems.
Yes.
But now it's becoming more this way and self-contained.
Today, the majority of the boats use this and
one?
this.
The newer boats?
That split unit is not used.
For older boats, maybe?
In older boats, you found that a lot of
Mostly
this.
these, right?
Because the distance between this and this is too far,
Right.
and you have a lot of refrigerant. That's not good.
For the split units, when you're putting
Turn off the cell phone.
more than, like if you have more than one room, is it just you're directing the air to more than one room, like a vent, or are you adding
In
more?
this unit?
Yeah.
Pay attention. We are going to refresh the split unit. The split unit, the evaporator, is located in the cabin.
So you would have more than one evaporator per
In
cabin.
a split unit, maximum 2 evaporators per compressor.
Okay.
No more than 2. In this system, you have
You can add more.
12 air handles with the same unit. The only that unit dimension is the capacity of the central chiller unit.
Okay.
This is a great design. It's more popular every day.
It's easier to work with.
Yeah, easy to install. In your company, you install the majority chiller, no?
Well,
And self-contained. Yeah.
We're doing a lot of self-contained
Yeah,
right now.
yeah.
On the chillers, we only have one big job that it was that one that I saw that it was like 120 foot, I think it was the boat.
Yeah.
It was like 24 chillers, 24 air handlers.
24
plus
air handles.
24 air handlers and three
And
chiller
3
units.
central units. It's basically one central unit for each 8 air handles.
On this boat,
Yeah.
they wanted it.
The recommendation
Who knows
is
why? But they wanted to have it on because on the
depending on the level.
yeah.
Yeah, it's in mega yachts and cruise boats. Yeah, for example, in cruise boats, when you take the Royal Caribbean, they are divided in port side apartments, starboard side. Each side is controlled for one chiller unit, and that chiller unit have air handles in each room. Correct? The other starboard side, other chiller unit. In
You
the
haven't
other
seen?
floor the same, in the other floor the same, in the other floor the same. It's basically chiller units per each corridor, per each.
Now the chiller units for cruises are huge.
Oh yeah. Let me excuse me.
I'm sorry. How do you determine how big of a tank you need of like those tanks?
This one.
Yeah.
Okay. This is other topic. This is okay. I want to mention right now. This is this is the cooling tower. The cooling tower is used in marine applications when you need do the service in a boat when the boat is out of the water in the marina. The boat is out of the water and the customer, the crew, they want to use the boat because they live in the boat and they need the air condition. Pay attention. Suppose that this is the boat. This is the boat. Or this one. Or this one. And I want to install the cooling tower in order to use the air condition unit when the boat is out of the water. This is the situation. This is a tower. This is a tower filled with fresh water. You bring the hose garden here. You bring the hose garden here. You fill with fresh water, and the pool in the bottom is full of fresh water. On top, you have a motor, AC motor, with a fan, and the fan is 2 speeds. Okay, and you have a pump. It's similar to the typical air conditioned raw water pump. The water suction enter here, and the water at high pressure enter here. Look at this, and the water enter here. Yeah, this is the raw water in the condenser, and this is the return, and this one, the return, will be connected over there.
So it's just replacing the
seawater.
The seawater with the cooling tower.
Correct. I replace the seawater with this tower, and I connect here and here.
the fan.
Pay attention. This element have a pipe in the middle, pumped the water over there, and the fan cool the water, and the water falls by gravity. And once again circulate here, and is cooled in the cooling tower. And the water enter low temperature again, and keep the unit working good. Okay, pay attention. Your job in the marina today is install the cooling tower in that boat in the unit of the saloon, because the people, the captain and the engineer, they have a meeting in the saloon at 2 p.m. You need to install the cooling tower for the air conditioned unit of the saloon, and turn on the air condition in the saloon because they have a meeting in 1 hour. Okay, what is the number one? The step number one in that job. You need to install this element in the saloon air conditioned unit, only in the saloon. They don't need air condition in any other part, only in the saloon.
Bypass the other ones.
Okay, number one is enter in the engine room and identify which unit is the unit for the saloon. Let me check the breaker. Let me turn on the breaker quickly. It's that unit. This is the unit. Okay, in that unit, or is that one? In this unit, I am going to disconnect. I'm going to disconnect the raw water, and right now I disconnect here, and I bring my raw water. I bring my raw water here, and the return over there here. Ready? I remove it, and now the raw water enter here, and the return here to the other side, and this one here. And now I start the cooling tower, I start the air condition, and no problem, because the coil of the condenser is cooled with the cooling tower. Everybody follow me? And that's it. When they finish the meeting, or they say, no, let's connect that cooling tower for 1 week, because we need, okay? And excuse me, you are the engineer in the marina. Every day you check that the cooling tower is working, the fan is working, that you added more water here. In some cases it's evaporated a little, and you keep that unit because it's your responsibility.
So this is more for like short term when the boat's out of the water, not necessarily to have it on the boat the
No,
entire time.
it's
Okay.
only for service when the boat is out of the water. That's for service, mommy. And where you found those cooling towers? In the marinas.
Okay.
You don't need that. Oh,
Usually they're rented.
you need to connect that one, because in some cases they call a technician to connect that unit. And okay, what is the element that you need isolate in the regular unit when you connect the cooling tower?
The compression.
No isolate, the raw water system.
Oh.
The raw water system. You need eliminate this connection and connect the cooling tower here. Start the unit before you start the air condition. Start the cooling tower. Verify that the water returns, the water goes up and goes down, and verify with your hand that the water coming down is a little warm. Okay, that's okay. It's circulating. And after that, you enter in the boat and you start the air conditioned unit. This is a very, very common job in marinas. Hey, my friend, connect the cooling tower for that boat right now, quickly. You need to go to. You need a lot of work, because you see.
It's not the same.
Doesn't match.
Home Depot fittings, adapter fittings to pass from here to here. 3 hours later, oh, it's good, but I have a leak. The fitting is not good. Until you finish. That job is not easy for the fittings.
Yeah.
No, Papa? That's okay? Where is connected the power of this unit?
AC to the main panel.
It's usually actually at the podiums.
To the wall.
Correct? Correct.
Or the
To the pedestal of the marina, to
they
the
have
power of the marina. This is not on the boat. This is outside, to the wall. Correct? This is not related with the
Directly with the boat.
unit on the boat. It's external. That's okay? Let me 1 second, take 1 minute pee break. I'm going to prepare a couple of compressors and I show to you the compressor.
What are you breaking over there?
Yes, sir.